Assalamualaikum warahmatullahi wabarakatuh. Okay, let's look at an example for heat equation. Okay, heat equation for case B. Okay, so which here for case B, both ends are insulated. Okay, the question is given, find the temperature distribution in a rod of length pi. Okay, a rod of length pi. That means here L is equal to pi. Okay, which is totally insulated. When it is insulated, automatically you know that this is case B. Okay, including the ends and the initial temperature distribution Fx equal to x 2 pi minus x. So this one is actually Ux naught, because here it mentioned that initial temperature Us naught equal to x times 2 pi minus x, and the temperature distribution satisfies the heat equation. Okay, here is the heat equation. So Ut equal to K Uxx. Therefore, K here is equal to 4. Okay, that's how you extract the info from your given problem. Okay, from the problem given to you. Okay, the solution. First, we need to let Uxt equal to x of x times t of t. Okay, because here it composed of x and t. That's why x of x times t of t. Okay, so del t is x t prime t, del squared u over del x squared is equal to x double prime x t of t. And we substitute both into the above given equation. Sorry, this one into the above given equation. So we will have this equation. Okay, x t prime equal to 4x double prime t. Okay, rewrite it as such. Okay, that means we separate. Remember, we want to use separation of variable. So we separate the terms t and also the terms of x. Okay, the constant should be with t. Okay, and here is equal to negative lambda squared. Okay, for negative lambda squared less than 0, of course it will be less than 0 because negative, right? So we will have this function. Okay, x double prime x over x of x equal to negative lambda squared. So it will be x double prime of x plus lambda squared x of x equal to 0. The next one is t prime t over 4 t of t equal to negative lambda squared, which means t prime of t plus 4 lambda squared t of t equal to 0. Okay, these are the two important equations which we change it into the auxiliary, or another name is characteristic equation. Here it will become m squared plus lambda squared equal to 0, where m is equal to plus minus lambda I. Okay, and then m plus 4 lambda squared. Okay, this one, right? Let me rewrite it first. Okay, m squared plus lambda x. Sorry, lambda squared to 0. And for this one, it will be m plus 4 lambda squared equal to 0. Okay, so we have m equal to negative 4 lambda squared. And hence, we have x of x equal to C1 cos lambda x plus C2 sin lambda x. Okay, previous example in case A, the question used A1, A2, and then B. For this case B, the constant that being used are C1, C2, C3. It doesn't matter because this is for constant. You want to use A, B, it is okay. Okay, so open your mind. Okay, that means right now we are going to use representative for constant C. So this one should be C1 cos lambda x plus C2 sin lambda x. So like next t of t is equal to C3 exponent negative 4 lambda squared t. Okay, negative it will be exponent mt, right? So Uxt, the temperature, is equal to x of x here times t of t. Okay, we apply the first condition, which is del u del x. Sorry, I didn't wrote it earlier. Okay, it should be del u del x 0t is equal to 0, which means here it is actually ux 0t equal to 0. So from here we know that x prime 0 because ux differentiate x, okay, with respect to x. So x prime 0, t of t equal to 0. Since t of t does not equal to 0, therefore x prime 0 equal to 0. Okay, s of x is this one. Okay, we need to find s prime x. So differentiate x. Okay, differentiate, we have negative c1 lambda sin lambda x plus c2 lambda cos lambda x. Why is there lambda in front of the trigonometric function? Because we differentiate the angle and bring it to the front. Okay, differentiate lambda x is lambda. So write it at the front. Differentiate cos is negative sin lambda x. Okay, and here c2 times lambda because we differentiate the angle. And differentiate sine is cos lambda x. Rewrite the angle. Okay, next, x prime 0 is equal to this one. Okay, it's better if you write it like this first. So x prime 0 is equal to, okay, equal to negative, okay, sorry for just now, negative c1 lambda sine 0 plus c2 lambda cos 0. Sine 0 would be equal to 0. That's why it is 0 here. Plus c2 lambda. Because cos 0 is equal to negative. Cos 0 is equal to 1. Okay. So right now we have c2 lambda equal to 0. Which means it might be lambda equal to 0 or c2 equal to 0. So first let's look for c2 equal to 0. Okay. We have here s of x equal to c1 cos lambda x because c2 equal to 0, right? So t of t is equal to c3 exponent negative 4 lambda squared t. Okay. U as t would be c1 cos lambda x times c3 exponent negative 4 lambda squared t then. Okay. Next, we apply the second condition. This one is for c2 equal to 0. Okay. Okay, del u over del x pi t equal to 0, which means here the boundary condition is ux lt, right? So ux pi t equal to 0. Okay, which means here x prime pi t of t equal to 0. Okay, so t of t does not equal to 0. Therefore, x prime pi equal to 0. Okay, s of x is this one. Okay, c1 cos lambda x. Okay, after we have applied the first condition. Okay, s double prime x is negative c1 lambda sin lambda x because we differentiate s of x with respect to x. Okay, hence x prime pi is equal to negative c1 lambda sin lambda pi equal to 0. Since c1 cannot be 0, so lambda equal to 0, which means sin lambda equal to 0. Okay, for sin lambda pi equal to 0, lambda pi equal to n pi. Okay, you can also rewrite it like this from here. It will be, okay, from here. So it should be like this. Okay, or sin lambda pi equal to 0. So sin lambda pi is equal to sin n pi. Okay, sin lambda pi is equal to sin n pi, and thus lambda pi equal to n pi, lambda equal to n. This is compulsory. You need to write for n between n from 1 to until infinite. Okay, and from here we have s of x equal to c1 cos nx, and tx equal to c3 exponent negative 4 lambda squared, right? So we have lambda equal to n, so n squared t. Okay, and from here we have u of n x t is equal to c4 cos nx exponent negative 4 n squared t. As I previously mentioned in the previous chapter, I would prefer if you can write the angle in bracket. Okay, and then for n equal to 1, 2, 3 until infinite, compulsory to write, where c4 here is actually c1 times c3. Okay, c1 times c3. Okay, let's look at the second condition. So, sorry, not the second condition, the second assumption. Let's say we take lambda equal to 0. Okay, because first we have c2 equal to 0, and then another one, or lambda equal to 0. So this one is for lambda equal to 0. So when lambda equal to 0, that means negative lambda squared is also equal to 0. And thus we need to redo the separable again. Okay, because lambda equal to 0. Okay, and from here we have x double prime x equal to 0. Okay, and t prime t equal to 0. So here we have m equal to 0. And here m squared, because x double prime, this is m squared equal to 0. So m1 equal to m2 equal to 0. So thus we have x of x equal to a1 plus a2x. And the next one, t of t equal to a3 exponent 0, which is equal to a3 then. Okay. 0 because here m equal to 0. Therefore, u x t is actually in bracket a1 plus a2x times a3. Okay. And from here, we need to apply the first condition back again. Okay, because this is the new UST. Okay. And then del u over del x, 0t equal to 0. What we are going to apply is actually ux. Okay, ux 0t equal to 0. We differentiate this u. We actually rewrite x prime 0, t of t equal to 0. So t of t does not equal to 0. We have this one, x of x. Okay, that means we have x prime 0 equal to 0. This is x of x. So x prime x is equal to a2. Okay, x prime 0 equal to a2, which means a2 equal to 0. Therefore, we are left with x of x equal to a1. Okay, uxt is equal to a1 times a3. Because here, okay, a2 equal to 0. So we are left with a1 times a3. Okay, a1 times a3 can also be written as a4 to make it simpler. Okay, another new coefficient. Okay, apply the second condition, condition 2, which means differentiate x here as this one, ux, but we substitute the value pi t pi, okay, equal to 0, which means x prime pi t of t equal to 0. Okay, because this one is ux, so we just need to differentiate x. Okay, and t of t does not equal to 0, therefore x prime pi equal to 0. Okay, and we have here x of x equal to a1. Okay, that means x prime x is equal to 0. Since x of x is equal to a1, which is constant, differentiate constant will be 0. And it actually suit what we have here. Okay, because ux pi t should be equal to 0. So x prime pi equal to 0. Okay, right now ust is actually ust is equal to a4. Okay, and thus it will be a combination. Okay, combination u and xt is equal to a4. Okay, this one plus the ust that we have obtained earlier. Where was it again? This one, if I'm not mistaken. Yeah, this one. un equal to ust equal to c4 cos nx exponent negative 4n squared t. And the next ust is this one, ust equal to a4. So a combination of both would be unst equal to a4 plus, open the bracket, c4 cos nx exponent negative 4n squared t, where n equal to 1, 2, 3 until infinite. Okay, we're going to apply the superposition principle. Okay, by using the superposition principle, we don't have to write for n equal to 1, 2, 3 until infinite anymore. We can conclude it in terms of summation. So ust equal to a naught, capital letter a naught. To make it easier, we write it in capital letter a naught instead of a4, a3, a1, etc. Okay, plus summation n from 1 to infinity, a of n. Okay, c4 is a of n. Cos nx exponent negative 4n squared t. Okay, the last condition, the third condition. Okay, condition 3. We have us naught. We have us naught here equal to 2 pi x minus x squared. Okay, so us naught is equal to a naught summation. This should be summation here, n from 1 to infinity, a of n cos nx equal to 2 pi x minus x squared. Since this is cos, that means, and also we have a naught here, we will be using Fourier cosine series. Okay, why is it this one just left with this? Because we substitute t equal to 0. Okay, exponent -4 n squared times 0 is equal to exponent 0, which is equal to 1. So it's just gonna be an cos n x then. Okay, and here to calculate for a naught, it will be 2a naught equal to 2 over n pi, integrate from 0 to pi, 2 pi x minus x squared with respect to x. Okay, why do we have 2a naught? Remember the formula for Fourier cosine series that we have learned previously. Fx is equal to a naught over 2 plus summation n from 1 to infinity an cos n pi x over L. Right. So this part should actually be a naught over 2. But instead of a naught over 2, this part we have only capital letter a naught. So it can be written a naught is equal to a naught over 2. That means 2a naught is equal to a naught. Okay. The formula itself for a naught here is equal to 2 over L integrate 0 to L fx with respect to x. Okay, this is how we determine a naught, small letter a naught. So that's why to determine the capital letter a naught, it's gonna be here. Replace 2 capital letter a naught at the place for small letter a naught. Okay, so calculate this one. Integrate, substitute the upper value minus the substitution of the lower value, and hence we have 2a naught equal to 4 pi squared over 3, which then can be written, a naught can be rewritten as 2 pi squared over 3, because this is actually for 2a naught. We just want the value for a naught. Okay, so next, we are approaching the end. Okay, a of n is equal to 2 over pi, 2 over L. Okay, so 2 over pi, integrate 0 to L, integrate 0 to pi, 2 pi x minus x squared, fx here, multiply with cos nx with respect to x. For this one, we need to use the tabular integration, because this is algebraic function times trigonometric function. Okay, for you, we're going to take the algebraic function. So you need to differentiate on this side. And dv is equal to cos nx, and you need to integrate on this side. Okay, differentiate appropriately until you get 0, because this is algebraic function. Is for sure you're going to get 0 at the end. Okay, and this one you need to integrate, and don't forget the diagonal line plus minus plus. Okay, substitute, back substitute in the equation. So we have an equal to 2 over pi, positive, positive, positive. So 2 pi x minus x squared over n sin nx. Positive, negative, negative is positive. Therefore, 2 pi minus 2x over n squared cos nx. Negative, positive, negative. Negative, positive, negative. It should be positive then. Okay. Positive here. Positive 2 over n cubed sin nx from 0 to pi. So after substitution, you're going to get this value, negative 4n squared. Okay. As usual, I will for sure do it with you. Okay. 2 over pi. Substitute pi, we're going to have 2 pi squared here. So 2 pi squared minus pi squared over n sin n pi plus 2 pi minus 2 pi is equal to 0. So you don't have to substitute that. Plus 2 over n cubed sin n pi. Okay. Minus, open the bracket. So this is 0 for x. So 0 minus 0 is 0 plus 2 pi over n squared cos 0. Okay, and then plus 2 over n cubed sin 0. Okay, close the bracket. Okay, sin n pi is actually 0. Okay, this one is 0. So sin 0 is also 0. This one is equal to 1. Therefore, we are gonna left with 2 over pi times negative 2 pi over n squared. Simplifying pi and pi, we will have negative 4 over n squared. Alhamdulillah, we obtain the same value. Okay, negative 4 over n squared. And therefore, UST equal to A naught, capital letter A naught. So 2 pi squared over 3 minus, it can also be put outside, to the front of the summation. So negative summation, and from 1 to infinity, 4 over n squared, exponent negative 4 n squared t cos nx. Okay, a bit of reminder, don't forget exponent. It is part of the UST. Okay, that's it for case B. Okay, I'm thankful if you stay with me until the end and do your revision, and hopefully you understand how to solve problem given for case B. Okay, thank you class. Assalamualaikum.